Hello, and welcome to the online workshop of the Pay As You Drive and You Save, or PAYDAYS, Insurance Actuarial Study Research Project, sponsored by the Federal Highway Administration. This research project is undertaken by Metropia, Inc., a fast-growing transportation technology and analytics firm headquartered in Tucson, Arizona, and the Illinois State University. The core research team includes Principal Investigator Dr. Yi-Chang, founder and CEO of Metropia, Inc., as well as Associate Professor at the Department of Civil Engineering and Mechanical Engineering at the University of Arizona. Co-Principal Investigator Dr. Yulen Ma, Professor of Risk Management and Insurance from Illinois State University. Co-Principal Investigator and Project Manager Dr. Shanbiao Hu, Director of R&D from Metropia, Inc., and Dr. Xiaoyu Zhu, Senior Data Analyst and R&D Team Lead from Metropia, Inc. Traditionally, auto insurance premium rates are based on static factors such as a driver's socio-demographic information, type of vehicle, and historical driving record. One main limitation of this approach is that those static and historical factors do not reflect the dynamic nature of driving risks. Recently, some insurers have started looking into a new auto insurance program known as Usage-Based Insurance, or UBI, or Pay As You Drive and You Save, or PAYDAYS, which aims to incorporate individualized driving patterns into actuarial pricing. While most current UBI or PAYDAYS efforts can be considered a major leap forward, most researchers and insurers currently rely solely on user GPS trajectory data, without considering other contextual sensitive risk factors in the surrounding environment that may also contribute to crash risk. In this project, we utilize a new approach that collects individualized driving behavior data from a smartphone's GPS module, combined with geographical network information and dynamic traffic conditions to identify driving risk factors and evaluate driving behaviors under various contexts. Here is the structure of our data collection framework. The multi-source data collected in this research provides unprecedented opportunities to reveal real-world activity patterns as to when, where, and how an individual driver performs. Combined with drivers' crash history and social demographic information obtained through a survey, we can evaluate driving behavior under various contexts and perform actuarial analysis to provide a link between contextual driving risks and crash rates. The findings of our study can help insurance companies restructure their auto insurance premium rating systems by incorporating individualized driving data. We collected our data throughout an 18-month period from January of 2015 to July of 2016. The total number of non-duplicated trajectory data collected was about 311 million, which translated to about 2.6 million miles traveled and over 106,000 hours of travel time. The total number of survey responses from PAYDAYS program participants was 525. Most of the drivers were from Tucson, Arizona, and Austin and El Paso, Texas. Collectively, 258 accidents were reported by 160 distinct drivers. After data screening, we were able to include driving records of 503 users in our analysis. This table shows the sample second-by-second trajectory data after combining the roadway geometry dataset and dynamic traffic information. The recorded data includes the latitude, longitude, and altitude of each particular GPS point, the heading of the vehicle, as well as the instantaneous travel speed of the vehicle. Vehicle acceleration and deceleration can be found at any given time by using the instantaneous moving speed data. Speeding and relative speed under different traffic conditions can also be calculated by combining and comparing GPS data with roadway geometry and the traffic dynamic database. After data collection, multiple variables are created to measure driving risks at the trip level. We first examine the characteristics of our second-by-second trajectory data and determine the appropriate bucket for creating risk variables based on each variable's distribution. We create trip-level measures and use different thresholds for defining risk levels. In our statistical models, we incorporate static factors used in traditional auto insurance pricing, common UBI risk factors, and also the unique contextual-based risk measurements that we are studying for the first time. We model both the probability of accidents as well as the number of accidents, calculate the probability of accidents considering corresponding risk factors, analyze the relative probability ratios and incidence rate ratios for drivers in each risk category, and compute and compare actuarially fair premiums for drivers corresponding to their risks. We also illustrate the potential underwriting loss resulting from adverse selection if an insurer does not price auto insurance according to a driver's respective driving risk factors. This slide summarizes our key findings. As expected, the probability of an accident is lower for older female drivers and those who have more driving experience. Among the common UBI factors, we also found that those with fewer vehicle miles traveled, fewer hard brakes and hard starts, and non-peak time travelers had lower accident rates. Our study also uniquely incorporates contextual sensitive risk factors. We find that speeding, as well as driving at a speed significantly different from traffic flow, are both highly correlated with the accident rate. We perform premium projection and calculate how much an insurer could possibly undercharge if it does not consider these individualized driving factors. For example, if we assume the average premium for a male driver that seldom drives over the speed limit is $1,200, according to our findings, premiums for a similar driver that tends to drive over the speed limit should range from $1,444 to $2,348. After taking the number of drivers in each risk category into consideration, our findings suggest that an insurer that does not include speeding factors in underwriting could potentially undercharge each male driver $482 on average as a result of adverse selection. The same can be calculated for the relative speed factor. An insurer could potentially undercharge a male policyholder by $726 if it were to omit relative speed information. These numbers highlight the benefits for insurance companies to take context information into consideration when calculating auto insurance premiums. With this research approach and findings, we hope that our study can further existing knowledge about driving exposure factors that are closely linked to crash risk, help insurers restructure their existing pricing models to allow for variation in premiums based on these characteristics, and provide the actuarial foundation for advanced forms of PAYDAYS insurance pricing. Thank you. Should you have any questions or comments on our research, please don't hesitate to contact us via the information on the screen.